I want to add a little bit to the difference of squares and remind you that the very first thing you do every time you factor is take out a greatest common factor. So no matter what factoring you're doing, the first thing you want to do is take out a greatest common factor. And number one, when I look here, I go, do I have a common factor? In this case, I do. I have a common factor of 2. So I'm going to factor out that 2 from the 8 and from the 50. 2 will go into 8 4 times, and that leaves 4x squared. And 2 will go into 50 25 times, and that leaves also the y squared. Now when you get to this point, be very careful that you don't try to create again another set of parentheses and put your sum. The only thing you're doing here is taking out the greatest common factor. It gets its own line or its own equal sign. Then you have an additional step, keeping the 2, don't lose it. I go back and say, hey, this is the difference of squares. What square gives me 4x squared? 2x. Minus what squared gives me 25y squared? 5y. And then this is where I write the 2x plus 5y also. So my final answer is all 3 of these terms, not forgetting the 2, and then 2x minus 5, 2x plus 5. In number 2, I look here, and not only do I have 5 in common with the coefficients, but I have x to the 3, x to the 1, so x to the 1 is also common. So 5x is my greatest common factor. You may still need to divide out. I'm hoping you can just see that by now. But if you simplify this fraction here, you have x squared minus, the x's cancel, and 5 will go into 80 16 times. So here's my greatest common factor. Again, don't lose that 5x, and I can factor this binomial is the difference of squares. What square gives you x squared? X minus what square gives you 16? That would be 4, and then you have x plus 4. Again, all of this is your answer. Don't lose any part of it. Growing just a little more, in number 3, we have, again, the difference of squares. Of course, the first thing I'm going to look for is a greatest common factor. In this particular problem, I don't have one. But I do notice that I have the difference of squares. So I look right here and say, I have 16. What square gives me 16 is 4. X to the 4th, I'm going to take half of that because I'm writing 2 different binomials, so that's x squared, minus what square gives you 81? That would be 9. And then I have 4x squared plus 9. But when I go back and look, I look again at this particular binomial and notice that it is also the difference of squares. So I would do what I call double factoring. So I have to factor this again. So this, what square gives you 4x squared? That would be 2x minus what square gives you 9? 3. And then I have the 2x plus 3. So this particular binomial factored into both of those. I keep 4x squared plus 9. It does not factor because it is a sum. It is not a difference, and I can only factor the difference of squares. So in my final answer, all of this should be included. Number 4, we grow even more. When I look at this particular problem, I notice between 2 and 1250 that I have a common factor of 2. So the first thing I'm going to do is take out that greatest common factor of 2. So this is a to the 4th. 2 will go into 1250, 625 times. And I'm looking at that. That's my greatest common factor that I've taken out. 625 is not a common number. So I think, could that be the difference of squares? And if I were to put in my calculator the square root of 625, that would give me 25. And that is a perfect square. So when I factor that, I keep the 2, and I remember to divide this in half. So this is a squared minus 25 times a squared plus 25. So I factored this as the difference of squares. But if you look right here, you again have a difference of squares. So this is, I guess, a triple factoring. So I keep the greatest common factor, and I'm going to factor this into 2 binomials. A minus 5, a plus 5. So what square gives me a squared, and what square gives me 25. And then I keep that sum of squares, a squared plus 25. That does not factor. So in this final answer, all of this must be included. So, of course, first, you always look for the greatest common factor. After the greatest common factor, if you have a difference of squares, make sure in your answer that neither of those binomials, especially the difference, is a difference of squares again. You may have to factor more than once.